In this video, I'm going to look at exact trig values, which I think quite cruelly are on the foundation GCSE Maths. They're probably more prominent on higher tier maths, but they do exist in foundation tier maths. One of these was in last year's exam. So I'm going to go through where exact trig values come from, and that may be of interest to you. You may more likely just want to know a neat trick on how to remember them, and I'll tell you where to skip to. Um, yeah, this little bit will be about where the special values come from. You may want to skip ahead to the next section, which is on the special table, if you're not interested in where these things come from. But I think they're quite nice. So there's two triangles. One of them is this one that we'll call triangle A on the left, and triangle A is an equilateral triangle, and all of the side lengths on this triangle are 2. Okay, I'm gonna cut this one down the middle, and before we do that, let's say that the angles, because it's equilateral, all of the angles are 60 degrees. So I've got a 60 and a 60. I'm not going to draw the one on the top just yet. And that blue dashed line, let's make that one a bit more solid, cuts this triangle in half, which makes this new side length along the bottom 1. And the height of this triangle, using Pythagoras, because I've made a right angle triangle, the height of this triangle is 2 squared, take away 1 squared, and it's 3. And then the square root of that is the square root of 3. Okay, so the height of the triangle is root 3. I've cut the 60-degree angle at the top in half, so I've just got 30 degrees there, 60 degrees at the base, and 90 at the bottom. From that, I can do 2 things. Well, 3 things in fact. So if I consider the 30 degrees at the top, I can say the sine of 30, which is the opposite divide the hypotenuse. So remember, the sine of an angle is equal to the opposite divide the hypotenuse. Well, opposite that 30 is 1. And the hypotenuse of this right angle triangle is 2. So the sine of 30 is 1 over 2, or 1/2. I could also take the cosine of that angle. So the cosine of 30 is the adjacent side, which is root 3, and divided by the hypotenuse. So remember, cos theta is the adjacent divide the hypotenuse, so cos 30 is root 3 over 2. And lastly, I could also take the tangent of that angle. So the tangent of 30 is the opposite over adjacent, but 1 over root 3, and if we rationalise that denominator, we get root 3 over 3. Okay, so there's 3 sets of special angles: sine, cos, and tan of 30. I could do the same thing by looking at the 60-degree angle. Okay, I'll go through this a bit quicker. From that 60-degree angle, the sine of 60 is equal to the opposite, root 3, over the hypotenuse, 2. The cosine of that angle, so cos of 60, is the adjacent, which was 1, over the hypotenuse, which is 2, 1/2. And the third and final one, tangent of that angle, so tan of 60, is the opposite over adjacent. Didn't write at the top, let's put at the top. Tan theta is opposite over adjacent, is root 3 divided by 1. I'm not going to write that, it's just root 3 divided by 1 is just root 3. There we go. Okay, and then there's another triangle. Okay, this second triangle is an isosceles triangle. And this isosceles triangle is a very special one, that it's got base angles of 45 degrees. If it's got base angles of 45 degrees, that makes the other angle 90 degrees. And then I'm going to set it up so that the two equal sides of this isosceles triangle are 1. And if it's right angled, 1 squared plus 1 squared is 2. And so the hypotenuse here is root 2. Okay, it's the square root of 2. Let's do the same thing again then. So we've now got a right angle triangle, so let's just work with the these angles. It doesn't matter which one we choose here. So let's say I've got this 45 here, the opposite of that, so let's go for the sine. So sine of 45, the opposite to that is 1, and the hypotenuse is root 2, so it's 1 over root 2. If I rationalise that, I get root 2 over 2. The cosine of that 45 degrees then is the adjacent, which this time is 1, over the hypotenuse, which is root 2. Well, it's the same thing as before, root 2 over 2. And lastly, we have the tangent of that angle, which will be the opposite over adjacent, is 1 divided by 1, which is just 1. Okay, so these are our special angles. Now, I've got to stress, you do not need to know where they come from, but some of you may have learned about this and think, I've got no idea where they come from. I've just been told to learn these things. What the heck are they? And that's where they come from. Okay, and these ratios come from special angles. Okay. If you've just watched that last bit, congratulations. If you haven't, don't worry. So I would suggest that you don't really need to know where these things come from for your GCSE. It's useful context, it's very nice to know, but if you're looking to just learn what the exact trig values are, here's the trick. Okay, so there are two functions that we're going to put into a table. Okay, we're going to look at the sine and the cosine. Okay, and the special angles we need to know are 0, 30, 45, 60, and 90. The next feature of the table I'm going to draw is a big square root. Okay, and then I'm going to have a division at the bottom by a big 2. On the top line, so my sine line, I'm going to have 0, 1, 2, 3, 4. And on my cosine line, I'm going to have 4, 3, 2, 1, 0. Okay, that's the table. That's the one thing you need to memorise, and from that we'll be able to work out any exact trig value we want. So I'm going to use that table to show you how I can work out any trigonometric value I like. So I'll repeat it again, and you might like to try this yourself, and I'm going to do it on every slide. So I'm working out the sine and the cosine, and then I want a big square root of 0, 30, 45, 60, and 90 degrees, and big division by 2. And then in my sine line, it goes 0, 1, 2, 3, 4. And in my cosine line, it goes the other way, 4, 3, 2, 1, 0. Right, let's use this then. So I'm going to first of all work out the sine of 30. Okay, so if I look at my table, I'm looking for the sine of 30, and that points to this 1. Okay, so with that 1, that means the sine of 30 is, remember it's under a square root, it's the square root of 1 divided by 2. Okay, well, the square root of 1 is just 1, so it's a half. Now, that is true. Okay, the sine of 30 is 1/2. I now want the cosine of 0. Okay, so look at a cosine, looking at 0, that leads to this 4. So I'm now directing to this 4. So cosine of 0 is the square root of 4 divided by 2. Well, square root of 4 is 2. It's 2 divided by 2, which is 1. Okay, the cosine of 0 is 1. Put it in your calculator and check. Cosine of 0 is 1. Okay, let's do this a bit quicker then. So sine of 45. So sine 45, I'm looking at this number 2. It's the square root of 2 over 2. I can't simplify that any further. There you go. And the cosine of 30, bottom row now. So let's go to the sink. So cosine of 30, see if you can do this without my help. Cosine of 30 leads to this 3, so it's the square root of 3 divided by 2. Okay, well, you may be thinking, rightly so, well, sine and cosine, I can do that with the table, but what do I do for tan? There's one more thing you need to know, and that's that tan is sine divided by cos. Okay, I've used a sort of triple equal sign there because that means identity. So the tan of an angle is identical to sine over cos. So what we're going to do is work out the sine of the angle, so the sine of 30 and the cos of 30, and then divide those things. Okay, so let's repeat that table. I recommend every time you see one of these, you try drawing it out. So we've got the big square root, we've got sine, we've got cosine, 0, 30, 45, 60, 90, and then all over 2. And then sine is 0, 1, 2, 3, 4. Cosine is 4, 3, 2, 1, 0. And that's not my neatest table, but there we go. Right, so sine of 30, using that, is the square root of 1 over 2, which is just a half. The cosine of 30 is the square root of 3 over 2, if you go through that. And so the tan of 30, okay, tan 30 is sine 30, which is a half, divided by the cos of 30, which is root 3 over 2. Okay, so to divide fractions, we keep the first one the same, we find the reciprocal of the second one, so 2 over root 3, and instead of dividing, we'll multiply, and that comes out as 1 over root 3, which rationalises to root 3 over 3. Okay, and that is true. Check it with a calculator if you don't believe me. Tan 30 is root 3 over 3. Okay, tan 45, see if you can do this one on your own. You might want to pause the video and give it a go. Okay, so we're going to work out the sine of 45, and that's the square root of 2 over 2. And then we'll work out the cos 45, that's also root 2 over 2. Well, tan of 45 is sine 45 divided by cos 45, which is going to be root 2 over 2 divided by itself. And anything divided by itself is 1. Okay, there you go, tan 45 is 1. Lastly, let's put this into an exam context then. So I think this could quite reasonably be right at the end of a foundation tier paper. We're in the first half of a higher tier paper, so we can do, and by that I mean paper 1. Okay, so you don't have access to a calculator for this. If you see this angle 30, if you see 30, 45, 60, okay, that should be triggering you to think, well, what do I know about those things? I know the sine and the cosine of 0, 30, 45, 60, and 90. Here's the square root of 0, 1, 2, 3, 4, 4, 3, 2, 1, 0, all over 2. Okay, I'm looking for AC, so that's the hypotenuse of this right angle triangle. Let's call it X. And then what do I know? I've got AB, which is the opposite side of this triangle, and I'm looking for the hypotenuse. So in SOHCAHTOA, I know, well, I've got the opposite and the hypotenuse, so that tells me I want to use sine, okay? The sine of 30 is equal to the opposite, 20, over the hypotenuse, which is x. Okay, or in the rearranged version of this, we've got x is 20 divide sine 30. I know from what I just did that sine of 30 is the square root of 1 over 2. So this becomes 20 divided by 1/2, which is the same as doing 20 times 2, which is 40. Last one, you might want to pause the video and give this a go, see how far you can get on your own. Okay, and on this one, I'm looking for the length AB. Let's call that one x. And then let's label this triangle up. I'm looking for the adjacent side of this triangle. We've got the hypotenuse, and if I go through SOHCAHTOA, that means I'm using cosine. Okay, the cosine theta is the adjacent divide the hypotenuse. So in this context, we've got cos 60 is equal to the adjacent, which is x, divided by 12. If I were to draw on my table, you'd find that cos 60 is 1/2, and that's equal to x divided 12. So x is 1/2 of 12, which is 6. Okay, make sure you do a reality check in these questions. You've done all this work. Is 6 a reasonable number? Yes, it is, because my hypotenuse is 12. That's the longest side in the triangle, so it needs to be shorter than that. It's not ridiculously small, so I'm happy you've done the right thing there. Okay, thank you for watching. I hope that was a helpful guide to exact trig values.